Okay, so we spent the last couple of days doing the vocab for this stuff. We're actually going to do some arithmetic with polynomials. Now, I said earlier, we're not going to be solving any sort of equations with polynomials. We're just going to learn how to kind of manipulate the pieces. There's 4 basic operations in math. We're going to add, subtract, multiply, and divide. You've done that your whole life. We're going to do that with these polynomials. It's very similar. The only thing is you have to kind of look at the big picture of the problem and then pick out certain pieces to actually add together or subtract or multiply or divide. So that being said, we need to talk about something called like terms. Now, like terms are individual terms of an expression that have the same variable and exponent. You're trying to find matches in this mess. So when I say that, I'm looking at like 4x is a like term for negative 3x, right? They have the same variable and the same exponent, right? Variable of x and an exponent of just 1. We did a lot of this when we solved equations. You know, you were trying to find the x's went together when you would add or subtract those, or the constants went together. But it's going to be a little bit harder because you're going to see the variable pop up multiple times, so you'll have to pay a little bit more attention to the exponent on it to determine if it matches up with another term. So 15x to the second and 7x to the second would be considered like terms. And then the 38x to the third, he doesn't match up with anybody, so there's no like term for him. Now, we are going to be adding these terms. When you add like terms, coefficients are going to change, exponents are not going to change. So if we wind up adding something like 2x to the second and 4x to the second, the result on that is going to be 6x to the second, not 6x to the fourth. Exponents don't change when you add, right? The whole purpose of exponents is a shorthand for multiplication. You have to be multiplying or dividing for exponents to change. They stay the same when you add and subtract. We're going to kind of break this up over the course of several days. We're going to spend a day adding. We'll spend a day or two on subtracting because it's a little trickier, believe it or not. Multiplication, that's the one we're going to spend the most time on because it's kind of crazy. All right, so we're going to jump right in. I'm going to give you a couple of polynomials, and I'm going to ask you to add them. I would like you to add them starting with the biggest exponent term first. The reason I'm asking you to do that is if you go through and add, the biggest exponent, and then you just kind of move down the line, you write your answer in what's called standard form. Standard form polynomials have the biggest exponent first, and then it just goes on down the line. So on this first example, our like terms are going to be the 9x squared and the negative 4x squared. You are adding integers, okay? There's no reason to overthink this. 9 plus negative 4 is 5, so 9x squared plus negative 4x squared is 5x squared. And then you move on to the next one. Negative 5x plus negative 5x is negative 10x. 10, trying to highlight these guys the same here. 10 plus negative 8 is 2. We came up with a quadratic trinomial. I'm going to kind of review this vocabulary kind of throughout all of this to keep popping some of the words up here in your life. So exponent of 2 means it's quadratic. 3 terms means it's a trinomial, quadratic trinomial. Okay, match up your terms. I mean, as silly as it might sound, take a second and it's worth the time so you know what you're adding together. Okay, so 3x cubed plus 3x cubed is 6x cubed. 6x squared plus negative 6x squared, that's 0, so there's no x squared term. You can have terms cancel out when you do this. I mean, zeros are zeros, so you don't have to bother with them. 7x plus negative 3x is 4x. And negative 1 plus 3 is positive 2. So I took a 4-term polynomial and a 4-term polynomial, and I came up with a trinomial. It's possible. All right, last 2 here real quick, and you notice these guys aren't in order. The first 2 kind of went piece by piece in order. So again, step back and look at the whole problem and then decide what to do after that. So I'm going to start with my x to the 4th terms. 2x to the 4th plus negative 6x to the 4th is negative 4x to the 4th. And then I'm going to move on to my squareds. That's 10x squared. And then my constants, that is -1. Okay, if you go piece by piece in order, your answer should kind of automatically be written in what's called descending order. You're starting with your biggest exponent and then working down the line. All right, biggest exponent I see is r to the fourth. Since there is no other r to the fourth term in the second polynomial, just drop that guy down. Then I'm going to go r to the second, 8r to the second, 4r to the second. That is 12r to the second. I'll cross these out as I do them so I don't get lost here. No other r term, so I'm going to drop the 8r down. And then 7 plus 1 is 8. Okay, just don't overthink these. You can't put together terms that don't have the same variable and exponent portion.